Good day, everyone, and welcome to this Gradle webinar. I'm your host, Trisha G. Today's webinar is Gradle Build Cache, Deliver Faster by Doing Less. There's a slight change of plans compared to the published agenda. Instead of Laura and Oleg presenting on this topic, it's Laura, our technical writer, and Akshay, our technical trainer. Feel free to ask questions using the questions panel as the session is presented. Your questions may be answered there, or if we can't answer them straight away or we want to answer them in front of everyone, we'll let Laura and Akshay know about your questions at the end of the presentation. One more thing before we start the session properly. I want to mention DPE Summit, Gradle's Developer Productivity Conference in San Francisco in September. Tickets are still available, just about. So if you want to hear the latest about developer productivity from Gradle, Netflix, Uber, Intuit, Meta, JetBrains, Atlassian, and Microsoft, amongst others, now is a really good time to grab your ticket before they go up in price. Without further ado, welcome Laura and Akshay. Hi, team.
Thank you, Trisha. Welcome to the Gradle Build Cache webinar. I'm Laura Kasovic. I'm the technical writer at Gradle. I'm a huge open source advocate, and my background is primarily in hardware. I've worked on 3D printing and other sensor startups, but I love software as a hobby. I love Gradle, and I love building communities. I am joined by Akshay.
Hey folks, I'm a technical trainer here at Gradle. My previous experience includes doing development as well as build engineering, and I'm so excited to be here with you here today.
So today's agenda, we're going to cover three really important topics. We'll start with incremental builds, then we'll cover the local build cache, and finally the remote build cache. Then we'll do a little tidbit about troubleshooting cache issues. Now, as Akshay and I demo items today, we're going to use the Gradle Build Tool, of course. We're also going to use build scans, and you'll see us use Develocity. Now, Gradle Build Tool, I'm just going to keep it short and say Gradle for the remainder of this webinar, and that's, of course, our open source build system. Develocity, that's our commercial product. It provides build acceleration and observability, and it includes many advanced features like remote build caching, build scans, test distribution, performance dashboards. We're going to use some of those features in our demos today and talk about them. What's really neat about Develocity is that it doesn't just integrate with Gradle Build Tool, it also works with Maven and Bazel and SBT too. So let's have Akshay cover incremental builds. Akshay, you're up.
Thank you, Laura. I'm going to share my screen. So if you think about it, a Gradle build consists of a number of tasks being executed. So for example, you might have the compile Java task execute, you'll compile your tests, you'll execute your tests, and so forth. And each task has inputs, an action is performed, and outputs may be produced. And usually it's the execution of the action which really takes a long time. So you, for example, if you have the compile Java task, the inputs are the source files, and then the compilation happens, and then bytecode is produced. Now, if you think about it, inputs can be more than just source files. So if you change the Java version or you change the compiler options, different bytecode will be produced. So it's important to understand that inputs can be files as well as configuration options. And then, if you have a lot of files that are being compiled, the action will take a long time to execute. And it's really the expensive part of each step of the build. The thing is that many tasks are deterministic. So our example here, the compile Java task, if you have the same inputs, that is the same source files, as well as the same, Java version, compiler options, and so forth, every time you run that task, it's going to produce the exact same bytecode. Same inputs will always produce the same outputs each time you execute that action. So we can use this to sort of save time. If we realize that, if we have the outputs from the previous time we've executed and we're executing the task with the same inputs, we can save some time here. So we do a build, the compile Java action runs, it looks at the source files and all the compiler options and so forth, it produces bytecode. We run the build again, the compile Java task is about to run again, and it realizes that, hey, I already have the bytecode from the last time I ran. let me look at my inputs. They haven't changed. So I can reuse the bytecode that I have. I don't need to actually execute the expensive action. And again, once keep in mind, if you have a lot of files that you're compiling, it will take a significant amount of time. So if we just did some tracking, we track the inputs that were used to create the outputs that we currently have, we can potentially save a lot of time by just reusing the output instead of running that action again. And Gradle, very early on was this feature was added to do this sort of tracking, and it's known as incremental builds. So Gradle uses the cached task outputs from the build directory, and if the inputs are the same, and the task is deterministic, it can reuse those outputs from the build directory. It doesn't need to run that action again. And you'll see this in the console output. Whenever you execute tasks, next to the task, there is an outcome label. And if you see the up-to-date outcome label, that is telling you that, hey, Gradle reused the existing outputs in the build directory because it noticed the inputs have not changed, and this task is deterministic, and so it didn't have to run that expensive action, and it saved you some time. So up-to-date means we just reuse the existing output. If you think about it, the way to summarize what incremental builds do is if you just did some deterministic work locally, don't repeat it. Now, just having incremental builds is awesome. It saves you a bunch of times in many use cases, but there are limitations in some use cases where it's not able to help you. So for example, if you're working on a feature, but then there's a priority bug that came in, you switch branches, you start working on the bug, you do builds, you submit a pull request, you go back to your original branch, your build directory has outputs that are now different, created with different inputs for the bug that you were working on. So back to your feature, now those outputs in the build directory can no longer be used. And when you run builds, it has to rerun the actions, even though, some time ago you had the correct outputs available. If you're doing some experimental work, let's say you're testing changes to a function you're writing or a method, you're doing some performance analysis, you keep making a lot of changes, and at the end you realize, okay, the original implementation was better, you revert all your changes, but you can't go back in time, you don't have those old outputs still, so when you do builds, it's going to have to run the actions again. And of course, if you ever do a clean, you delete the build directory, you've lost all the outputs, and you actually, incremental builds is not able to help you, then it does need to run the actions again. So if you look at the experimental changes scenario, let's say you have your inputs, your source files, you run the compile Java action, and you generate bytecode. Then you do some testing, you change some of the source files, you run the compile action, and it generates different bytecode. You change your mind, you go back to the original Java files that you had. Now think about it. Wouldn't it be nice if somehow you could reuse the bytecode that was available, just a few minutes ago? But no, the build directory has the bytecode created with different inputs. So it has to run the action again. And keep in mind, for very large projects, this is very time consuming, and it has to run that expensive action and produce new bytecode once again. So Gradle was then modified, to handle these sort of scenarios and continue to try to improve performance. Gradle introduced a local build cache. And the idea is, what if you had access to more than just the previous build task outputs? What if you had a historical build task output access? So again, if we look at our scenario, you have your inputs, you run the action, you produce bytecode. What if you store mappings of inputs and outputs in a local cache? So you run the build, it does this. It'll create a cache key from the inputs. It basically looks at all the inputs for the task. It creates a hash of that, and then it compresses the outputs, and it stores this in the cache. So it uses the hash of the inputs as the key, and then it stores the compressed outputs in that cache. So again, you're doing your experimental work, you change some source files, you produce new bytecode. Once again, once you run the build, a hash of the inputs and the compressed new outputs are put in the cache. You change your mind, you revert your source changes. Now, if you do a build, if the current outputs in the build directory don't match what was used to create them, so if the inputs are now different, it'll look at the local cache first. It'll create the hash of the inputs. It'll look up the cache. If there's a hit, it'll take the outputs and put them in the build directory and use that. And it doesn't need to run that expensive action. So this covers a lot more use cases for performance improvements than just incremental builds. And now when you run a task, you'll see a different outcome label if it actually queried the cache. So you'll see, like, usually you see like up to date. That indicates that it used the outputs available in the build directory. But if you see the outcome label from cache, that is telling you that, hey, Gradle Build Tool saw that the outputs in the build directory were created with different inputs. So it queried the local cache or a cache and says, okay, I found matching outputs there that were created with the current inputs that you're using. I'm going to use that and put that in the build directory and not run that expensive action. So the from cache outcome label indicates that it's using the cache. So if we go into the details a little bit, so the cache keys are really a hash of all the inputs involved. So for the compile Java task, for example, you look at the source files, you look at the JDK version, you look at the dependencies, the compiler args, and so forth. If you think about it, if you're compiling with a different JDK version, that is going to result in different bytecode. So the compile Java task needs to tell Gradle Build Tool that, hey, JDK version is an input. The compiler args are inputs. And so the compile Java task has been configured to share all of these details with with Gradle and say these are the inputs that you need to look at when you're seeing things have changed or creating that hash. And then of course the entry in the cache is just the compressed output. In this case, it's the class files that are created by the Java compile task. So I will also want to mention that for all the built-in tasks that Gradle provides, they've been configured to correctly configure all their inputs. So when hashes are created, everything is done correctly. For tasks, custom tasks that you author, you need to do this yourself if you want it to work with the build caching. You need to configure what all the inputs and outputs are so that it's able to create that input hash correctly and compress the correct output and store that in the cache. And this can be a source of problems if you forget to define an input or something like that. And we'll cover that in the troubleshooting section a little bit as well. So the idea of incremental builds was if you just did some deterministic work locally, don't repeat it. The idea of local build caching is if you recently did some deterministic work locally, don't repeat it. So it covers more use cases than just incremental builds. So by default, local caching isn't enabled with Gradle projects. You have to enable it. The best way to do this is to go to the Gradle properties file. You could do that with the project, the properties file associated with the project, and set the org.gradle.caching to true. Now, if you don't want to do this for every single project you're working on, you can do this in the Gradle properties file in your user home directory. That's an option as well, or you can do it per project if you want to. Now, if you don't have the caching enabled and you don't want to enable it for the whole project, but you just want to use it for specific tasks, whenever you execute that task, you can pass -- build cache, and then it'll use the build cache for that execution. And then, like I mentioned, sometimes, especially for custom tasks you author, you might notice that it's not working the way you intended it to work with build caching. So then there are a few options available when you're debugging. You can use the free build scan service by passing the -- scan flag. I'll show a demo of that. Or you can pass the -d org.gradle.caching.debug equals true. And it's going to show you some more information locally as well. Now you might be wondering, okay, you set this to true in your Gradle properties. Where is the cache? Where is the local cache being used locally? There's a default location where Gradle uses a local cache. It's in your Gradle home directory. This is also configurable, but I do recommend just leaving it and using the default location unless you're doing some experiment or something like that. Okay, there are some other configuration options you can set for the local cache. By default, cache entries are only valid for a week, for 7 days. If you wanted to change that, you can use the removed unused entries after days. So in your settings file, you go and you add a build cache local configuration block, and then you say removed unused entries after 30 days, you can set it, for example. Now, I want to mention in Gradle 9, this is going to be different. You're going to have a caches build cache in addition to a build cache local section, and there you'll define the removed unused entries. The other thing you can define is where you want to have the cache be for the project. Like I said, there's a default location. Most of the time, you just want to leave it to that. But if you want, you can set the directory to some other location. This is still going to be the same even in Gradle 9. You'll set build cache local directory. It's just the removed unused entries that is going to be in a separate location. Cache is build cache. And once again, all of this is going to be in your settings file. With that, let's go over some quick demos. So I have a very simple project here. It's the Hello World project that gets created when you run Gradle init. Real projects are, much more complex and time consuming, but for the demo, we'll just use a simple project. So I'm going to go ahead and just run the compile Java task. And you can see the first time it runs, there is no outcome label next to the task. That means the task action executed. You can ignore the demo prep task. It's something that I have for this demo. It's just a side effect task. You can just leave it for now. If I run the task again, compile Java, you will see the up-to-date outcome label. That is indicating that, hey, in the build directory, the bytecode was created using the same inputs, so it's just reusing that. Again, I didn't change any source files, I didn't change any configuration options, so you can just reuse that. Now, let's say I go ahead and change a source file. I come over here and I change the source file. I'll add an extra exclamation over here. Now, source files are different, so if I run the task again, it actually has no outcome label to it. It's no longer up to date, and it produced new bytecode and put that in the build directory over here. Now, if I run it again, it is up to date. Keep in mind, like I mentioned, inputs can be more than just files. So this is an input file I'm changing, but it can also be configuration options. So I'm going to head over to the build file over here. And by default, the bytecode that is produced here has debug information in it. That way, when you run your application, you can attach a debugger to it and do some querying. But let's say I decide I don't want debug information. So I set this to false. I set the options.isDebug to false for the compile Java task. Again, this is a compiler option that I'm changing. Now, if you think about it, this is going to result in different bytecode that does not have the debug information in it. So this is actually configured to be an input that the compile Java task, looks at. So I have changed one of its inputs, and therefore when I run the task now, it's no longer up to date. Different bytecode get produced and gets stored over here in the build directory. Now, if I change my mind and I say, oh yeah, I actually do want the debug information, the current output over here does not have the debug information. Even though a few seconds ago I had that output, I don't have it right now in the build directory. So when I run this task, it does need to execute again. So let's go ahead and now enable the local caching and see that in action. So I'm going to run a clean quickly just to reset things. So I'm going to go over here in the Gradle.properties, and I'm going to set org.gradle.caching to be true. Now, in the settings file, I do have build cache local. I do have a different directory configured. This is just for the demo. Like I said, usually you don't want to do this. I'm just going to have the build cache be over here as well, so we can just have a quick peek at it. So I have enabled caching. Let's go ahead and run the compile Java task with the debug information set to be true currently. So we set that. You'll see a build cache directory got created, and there's something in there. We won't go over this in detail, but you can see there's some sort of hash entry in there. So we'll go ahead and now run it again. Things are up to date. So that's looking at the output in the build directory itself. It doesn't need to query the cache. Let's go ahead and change our debug to be false now. We don't want the debug information in the bytecode. And if we run this now, you'll see that it did have to execute, and there was another cache entry created. If you see, there are 2 entries in here. Let's go ahead and revert our change. Say, oh, we change our mind. We want the debug information, and we'll execute the task. You'll see the outcome label from cache now. So that's telling us is that it looked at the output here. It did not match. It was created with different inputs. Gradle is tracking the inputs that were used to create this output. And it's like, okay, I can't use this. So now let me query the cache. And it did find that, hey, the cache does have outputs that were created with the inputs where the debug flag is true. And it went ahead and use that and put that in the build directory over here, and it did not run the action. So it could save you some time, and you'll see that from cache. Now, like I said, this is a quick demo project. The compile Java task takes milliseconds, but in a real world example that Laura will be showing you actually later, there are significant time savings by using a local cache like this. Okay, so now let's say, just to cover the debugging aspect of things, if you were, like I mentioned, the built-in tasks like compile Java, so forth, are very well tested and configured to work with the local cache. They declare all their inputs correctly and so forth. But if you're writing a custom task and you were having some problems with it and you wanted to try to figure out what's going on with caching, there are a few options available to you. Let me run a clean quickly. So the first option is you can pass the -i flag. This is just information, and it'll give you some very, very basic information. It'll say, yeah, I loaded a cache entry for the task, and this is the cache key. So it'll show you that final cache key that gets produced, the 897. And you can see the cache does have an 897 in here as well. But this is very basic. What if you wanted some more information? So you can actually use the -d org.gradle.caching.debug equals true. And this is there in the documentation. You don't need to remember this flag. But if you pass this flag now, it'll show you a lot more information. It'll show you exactly all the inputs that went into creating that final hash over here. And you can see there are a number of inputs for the compile Java task. There are the Java compiler information, the JDK version, the Java version. Here is our options.debug. We have our class path, which is the dependencies. If one of our dependencies changes, it does need to recompile. We have the source files as well, which is here, the stable sources. You can see here is my app.java file and so forth. So that all the things that went into creating that hash key are available for you to inspect, and they have associated values as well. So you can see the options.debug here right now has a value of F6D. F6D. So if I change this to false, right, and if I rerun it, you'll see the value is different now. It is C06. C06. And this one change causes a new hash to be created, the 610. So, something you can do is like run a build with the debug, save that to a file, then run a build with the debug, save that to a file, then sort of do a diff and see what changed, right? But this is kind of cumbersome, and it's not fun doing this. So a better solution is you can use the build scan service. So what I can do instead is if I run the compile Java task and I can say --scan, it's going to ask me, do you read the terms of service? You agree to them? You can say yes. I'm just going to go ahead and run it again. I'm going to change this back to true. And I'm going to run this again. And we can actually inspect one of these scans now. And this opens up in a browser. And Laura will go over this for another example as well. But in the build scan, there's a lot of information available about your build, what all happened. You can go to the timeline over here on the left. And you can look at the task here and open it up. And it'll show you that, hey, one of your inputs, the options.debug, had changed for this task. And it'll show you exactly that piece of information. So instead of like trying to, compare these outputs, diff files or something like that, you just run scans, and the scans will show you exactly what is changing for your task. And it'll give you like other information like the hash and so forth. So build scans is a free service that you can use for your Gradle builds. And it can give you a lot of great insights, especially like when you're debugging caching behavior for custom tasks that you author. It can show you some very, very useful information. Okay, and I think that is it for our demo.
So I actually covered everything that happens on your local machine and all the redundant work he can avoid himself. But what happens when you start sharing that work across an entire team? That's where remote caching comes in. Now imagine I'm part of the team, and I just merged a PR into the main branch. Now the CI machine is going to build my latest commit from the main branch and store the results in its cache. And actually, he's working from home. He doesn't have that cache entry locally. He pulls the latest code, he runs the build, and Gradle ends up doing the same work that's already been done by the CI. And that's completely wasted execution. And think about it, we scaled that up. It's not just Akshay, it's not just me, it's dozens, maybe hundreds of developers, all repeating the same work. Without remote caching, every developer and every single CI agent is stuck rebuilding the same thing. And remote caching breaks that cycle. Remote caching essentially lets multiple machines share a common build cache so that tasks don't need to be re-executed if their outputs already exist from a previous build, even if that build happened on a different machine. And that's, again, on top of incremental builds and local builds. So what does that mean? Well, when Gradle checks whether a task can actually be skipped using the build cache, it has to follow a specific lookup order. First, it looks in that build folder. If it's not there, it checks the local build cache. And finally, if it's not there, it checks the remote build cache. So this ordering really ensures the fastest possible retrieval first, and it falls back to the broader caches only when it's absolutely necessary. There's one more thing we got to consider. Who should really be pushing to the remote cache? Because not all task outputs are worth sharing. Think about it. I'm a developer on my machine and I'm doing lots of experimental or maybe incomplete builds. They're probably not useful to Akshay and the rest of my team. And worst, maybe from a security standpoint, my machine gets compromised and I'm pushing invalid, maybe malicious artifacts to the shared cache. That's bad. So who should really be writing to the remote cache? Well, in most organizations, it's going to be CI machines. They're the only ones that are allowed to push. And that's because CI builds run on clean, trusted environments. They only push outputs for committed changes coming from the main branch or really important development branches. They're reliable, they're validated, and they're actually worth sharing. So developers like me and Akshay and other CI agents, we can read from the cache. We can benefit from those already computed outputs without the risk of polluting the remote build cache. So out of the box, Gradle supports remote build caching, but you will need to set up and maintain a remote server that acts as a build cache yourself. We do provide a Docker image to help you, but it is up to you to handle auth, manage storage, deal with load balancing, and that's a lot of heavy work. So that's why one of the features of Develocity is the remote build cache. It's essentially a specialized server that's designed to store and serve cached build outputs across your entire team, including your CI infrastructure. It scales really well and it's very easy to manage. Now, Develocity actually supports and sponsors a number of open source projects in the Java ecosystem. And one of the ones we're going to look at, so we're not just looking at hello world builds like Akshay's demo, is the Spring project. Spring is a really popular Java framework. It's a fairly large project. The Spring Boot, Spring Framework, Spring Security projects all use Develocity for their local and CI builds. You can actually check out their GitHub because they use GitHub Actions as their CI/CD. We'll see in a moment, their CI builds heavily leverage the local build cache. If you're curious, and we're going to look at this in a second, you can check out their live public instance of their Develocity. The cool thing that we're going to see is that when Spring started using Develocity, they saw their CI builds run 4 times faster and their local builds run 15 times faster. And that's not seconds we're talking about here, that's minutes and sometimes hours. We're also going to look quickly at another project, the Detekt project. It's a static code analysis tool for Kotlin. It's actually a plugin on Maven Central. You can check it out too. They use Develocity for their CI builds. They also use GitHub Actions, so you can take a look at their workflows. And you'll see they use a different strategy. They heavily leverage the remote build cache. And again, I've got their live public instance URL here, but we're going to take a look at it right now. So let's do a demo. Let's take a look at the dashboard for Spring. This is a list of all the Spring builds that happened today. Some of it are coming from users. Most of them are coming from GitHub Actions. Let's just pick one right here. Let's do this latest one. So this is really cool. You get a lot of features here. We're only going to spend time on a few. First, the timeline. We saw this really quick with Akshay. Every single task that Gradle had to perform in order to generate the Spring Boot build is here. And you can see, once again, we're getting lots of from cache outcome labels. We can check out information here. For example, here we got a build cache hit, and we can see the original build that actually populated that cache. That's very neat. We see, you can inspect these as much as you want, but right now we're going to head over to the performance tab. And here, what we want to take a look at is task execution. Now, this is really neat. Take a look at this. Avoidance savings. In this particular build for Spring Boot, the local build cache hits saved them over 4 hours of build time. That's huge. That's huge. And again, I spoke about this earlier. They're not really leveraging the remote build cache, so only 3 seconds in savings there. And that's fine. That's just their methodology. You can actually take a look at these other items if you want to see which of the tasks executed were cacheable. We've got a list here. And if you want to see which ones were not cacheable, we had to execute no matter what, you can get a pretty good idea what those are here. And maybe if you feel like it, you might want to take the time and make those tasks cacheable if possible. Last but not least, if you're interested, we do have a build cache section up here. You can see the number of hits locally, 2,000. That's really incredible. Let's take a look at the Detekt project that we also mentioned earlier. The Detekt project is all CI runs. Let's take a look at this latest build here. It's a smaller project, so we don't expect as much in terms of savings, but they're getting lots of savings nonetheless. Again, here's the timeline, really neat. We're seeing, look at that, we're seeing a lot of up-to-dates. And performance-wise, when we go over to the task execution side, again, in this case, they're doing things a little differently. Local build cache, 0 seconds in savings. Remote build cache, 42 minutes. That's just the way they have it set up. 42 minutes. That's incredible. Again, we see the same thing here. If you want to look at cacheable, not cacheable tasks and how many hits you've got on the caches themselves, you can take a look. This is really neat. Again, it's all live and it's public information. If you're curious, check it out. It's really interesting. And that concludes just this Spring and Detekt demo. Basically a look at what real much larger projects look like when you're building them with Gradle and Develocity. One more thing I want to mention is Develocity's distributed caching. Some of this is new. So if you have globally distributed teams, the remote cache latency can really slow things down. And so we have this new Develocity service called Develocity Edge, and it places built cache nodes near your developers' NCS systems so that now you're not impacted by this latency. There's a replication of those cached outputs somewhere really close to you. Think of it as a CDN for your build outputs. And this replaces older cache nodes with a much simpler, high availability solution that really, really is easy to manage and works for highly distributed teams. So with that, I'm going to hand it back to Akshay in a second. But before you take over, Akshay, I want to just go over things one more time. This is everything we learned. Incremental builds. If you did some deterministic work locally, don't repeat it. Build caching on the local side. If you recently did some deterministic work locally, don't repeat it. And finally, remote build caching. If you recently did some deterministic work globally, don't repeat it. So with that, Akshay, let's do a demo.
So as I showed, we only went over like simple hello world use cases and we were running only the compile Java task. In real world scenarios, you'll have several tasks running with several sub projects, and you'll see like the from caches saving you time, or even like in some cases when you change like a task downstream, before that, there are all the tasks that ran before that can still utilize savings from caches and up to date and so forth, and then only after that they get impacted. So more real world examples that you got to see over there. Okay, back to our scenario here. Let's say we have things working nicely. We have incremental builds helping us out. We have our local cache, but we want even more savings now. We want the remote cache enable. We can enable the remote cache. Again, you have to set up the remote cache server. So I'm going to use a Develocity instance. So I'm going to go to my settings file here. The first thing we need to do is apply the Develocity plugin. I'm going to go do that. And then I need to define where the server is for Develocity. So I'm going to use our DPE University Develocity instance, which is where you can take training courses. And then I'm going to, under build cache, instead of local, I'm going to have a build cache remote as well. And I'm just going to say, use the Develocity build cache. So this is the Develocity server. There's a build cache associated with it. I'm just going to say, use that. And then I'm going to set is push to true. Like Laura mentioned, you usually only want the CI machines to push to the cache. I'm going to set it to true for the purposes of this demo, though. Now, I want to reiterate, once you do this, you still need to have the org.gradle.caching to be true. So if this is not true, either in your properties file here or your user home Gradle.properties file, all of this is not going to take effect. So you do want the org.gradle.caching set to be true over here as well. So we've gone ahead and do this. Let's go ahead and do a clean. I'm going to do a compile Java. I don't need to pass in the scan anymore. And you'll notice that even though I'm not passing the, let me go ahead and actually delete the local cache so I have a clean environment. Sorry, let me go ahead and do that. I'm going to do a clean. Okay. So even though I'm running these tasks and I'm not passing a -- scan, you will see that build scans are created for us. And that's because we're using Develocity. As soon as you do that and you apply the Develocity plugins, scans are automatically going to be available for you for providing all that analysis information you want. So let's go ahead and change the options.debug again, or the example that we've been using. We'll set it to false. We'll run the Java compile task. And let's take a look at the build scan that's created. And just like Laura showed, we'll go on the timeline here. We look at this and we can see the information in more detail now. So we can see that it first looked at the local cache. There was a miss. Then it looked at the remote cache. There was a miss. So then it ran the action, produced output. It stored that in the local cache, and then it stored that in the remote cache as well. And I can do some interesting things here. So I can, let's say, I'm sort of simulating another machine I have that does not have the local cache yet. So let's say the local cache is empty over there. So I'm going to delete the local cache. And I'm going to run the Java compile task here. And, before I do that, so I want to delete the local cache. And I want to delete the build directory because I don't want the outputs to be available in the build directory. So now if I run the Java compile task over here, it doesn't have the outputs in the build directory. It does not have a local cache, but you will see still the from cache outcome label. And if we look at the build scan and see the details, you will see that it says that, hey, I did not find it locally in the local cache. I found a hit remotely. So the remote cache had it. So it downloaded that from the remote cache and stored it in the local cache then. And so for future usage, it's available in the local cache. So that's like a quick scenario where if you were on another machine, there were no builds done on that machine previously. So the build directory wasn't there. There was no local cache. The remote cache hit, saved you some time. It got the output from there and it was able to use that. That's it for this part of the demo.
That was a nice use of the remote cache there, actually. Thanks for that demo. So last but not least, let's just go over troubleshooting. So you're going to come upon some build cache issues. There's a couple things that are going to happen. First, once in a while, you're going to expect a hit and you're going to get a miss. You're going to want to know why. A lot of times those misses or those issues come from things like absolute paths or timestamps. You're also going to hit issues when you're writing custom tests. So a lot of the tasks that come from Gradle, they're already highly cacheable. But when you're writing your own task, you have to take care of making sure the inputs to that task are well defined so that the task itself can be cacheable. The best way to help you debug issues with the cache is to use a build scan. And actually highlighted this a little bit today, but he's actually going to show you what happens when you compare two build scans. So actually, let's go back to you real quick.
Okay, so back to our demo project here. I'm going to run a clean again. I'm just going to reset everything, delete the local cache. Fantastic. So I'm going to do, I'm going to run the compile Java task, and I'm going to go ahead and change this to true, the options.debug, and run it again. And let's go ahead and inspect our cache. So, inspect our build scan. Now, one thing you can do is you can actually go and view all your build scans, and then you can select two of them, any two scans, and on the bottom right, there's going to be this compare button, and you can hit that. And it'll then do that analysis for you, and it'll compare these two scans. It could be any two scans, not just the two next to each other. You can compare like a much older scan. What all changed between these two builds that I did? What inputs changed? And here I just have one example, one compile Java task, but for each task, it'll show you all the inputs that change. So we're here saying that the options.debug for this Java compile task change from the first build scan to the second build scan. And it'll show you the exact hash keys that were involved, and so forth. So if you were trying to debug custom tasks that you author and you had several of them running and you saw weird behaviors, this information would show you can use the build scan comparison to see exactly what the inputs are changing from a current scan to something that happened last week even, and sort of help you do some debugging and some analysis.
Thank you, Akshay. So that concludes the three important topics in our agenda: incremental builds, local build cache, and the remote build cache. We even covered a little bit of troubleshooting. So what can you do now? Well, try out the local build cache in your build and consider using a remote build cache. And take a DPE course. DPE University offers a number of courses you can take, and after this one, we highly recommend the Gradle Build Cache Deep Dive. It's a complimentary course, and you'll learn a lot more than we covered today. If you're feeling up to it, check out their user documentation and think about contributing. Or if you find that we're missing some information, let me know by submitting a request through GitHub. Thank you so much. Thank you, Akshay, for your wonderful demos. Now I'm going to hop over back to Trisha, who's going to lead our Q&A.
Hello, I'm back. And the good news is we have quite a few questions. Oleg was busy answering a whole bunch of them in the chat, and also suggesting that if anyone has something they want more detailed information on, or something they want to have a conversation about, to look at the community Slack, because it's a much better way of getting more conversation. So let's talk about some of the questions we've got here. I'm going to go through these in order. Right. First question is, are there default size-based eviction policies for the local cache, or just the 7-day?
I can take that one. It's just number of days. There's no size policy. There's actually a GitHub issue that was created, and this was discussed. I don't have it handy with me right now, but if you want, if you send an email maybe to training@gradle.com, I can reply to that with the exact link to that GitHub issue. It was something that was considered and decided against. So the only configuration is supported is time. It's eviction based on time.
Okay, next question. A lot of these are from the same person. So Will, we're going to answer all your questions now. Right. Some of these questions are kind of fairly similar, so I think I might come back to this one in a minute. One of the main issues I'm running into in my Maven Gradle port is the difference in the way they handle transitive dependencies. I know they use different resolution algos, nearest versus newest, but similar to my previous question, which I didn't ask, I feel like these kind of point to fundamentally different opinions. Could you talk about that? Now, I know this isn't build cache, so this is specifically about how dependencies are resolved. So if you feel like you want to park that question, we can also park that question.
Yeah, I think we'll part that question because this is more of a dependency resolution and maybe even a dependency cache question, which is outside of the build cache topic we're covering today.
Cool. Maybe Oleg, maybe if you can point the asker to some documentation that we've got, and maybe that might help.
So I already suggested a few times in the chat, if you have a big question, just as we shared, there is a chat on the community Slack, just called caching. So happy to follow up on everything there, just ping me.
Great, thank you. Okay, one of these other questions, this is a good one. If there are multiple hashes for the same bytecode, then which one is picked up by the build cache during build? Did you get multiple hash codes?
Yeah, even Trisha was like, is that even possible? No. So what we do is we use hashes for the inputs, not the actual output. The output we don't hash, so the bytecode that's produced is just the output, and that's just compressed and stored in the cache. The inputs are what's hashed, right? So we take a look at all the inputs that are involved, and we create a hash of that. And you really have unique hashes for the output that's created. Now, you could have a mistake in a custom task that you author, and you forget to map all the inputs. So it's only actually using a subset of the inputs to create that hash. And then you can have duplicate hashes created for different outputs, right? Because you're not actually considering all the inputs correctly. And in that case, like if you're only considering like 3 of the actual inputs when you have 10, those 3 will always be the same. You're changing some of the other 7 ones and you're creating duplicate hashes. Then you will get bad behaviors, because then you'll get cache hits and it'll pull out like an output from the cache that's not the correct output, and you'll see that weird behavior then. And that's again when you can use build scans and the debug option that I showed, and you can look at all the inputs that are actually being considered, and then you'll notice, oh, these are not all the inputs. I'm missing some inputs. So yeah, you should. If things are working correctly, you will never get duplicate hashes for different outputs or different inputs. If things are incorrect, that's when you will get that. Then you can use the debugging tools to help you out.
Excellent. Thank you. Next question. If we have multiple branches with similar code and pushing the cache to the remote server from the CI machine, will it get back to the developer machine when they build the respective branches?
I can take that one as well. Yes. If you are storing what you store in the cache is, again, like there are a couple of options there. As long as like the hashes are unique from the branches, because it should be like it has different inputs, so it'll be different hashes and there'll be different entries in the cache. You can also make the branch name as part of your input mapping if you want to. Some people I think do that. That way it ensures uniqueness, but it doesn't have to be. I feel that way. But yeah, so when the developer switches branches locally, they'll still get the entries from the remote cache because the CI machine put them there for the different branches. So yes, that will work as well.
Next question. What's the best approach? Having a nightly run to push the remote cache, or make it happen for every PR pipeline run?
I can answer that again. So you want to do it on every merge build, not on every pull request. So when a pull request is created, you don't want, and it does a build to validate that pull request, you don't want those outputs in the cache yet. Because remember, that's not finalized. It's not merged into the branch yet. The team may decide, oh, you need to make more changes to this pull request. And there might be a lot of back and forth that happens before that pull request is actually merged in. And keep in mind, when the pull request is sitting there for a month and it hasn't been merged in, nobody else is going to be able to see those changes. So anything that's produced by those builds are not usable by the rest of the team yet. It's only after a merge has happened where other people will do a git pull and they'll actually see those inputs now. Right. So you want the CI machine, the continuous integration machine, not the pull request validation machine, to actually be the one that updates the remote cache. So only after a merge has happened, the branch is updated, that build will then update the remote cache because others will see those inputs.
That's a great answer. Thank you. The next one. In a scenario of a large complex project that relies heavily on caching for time savings, I imagine that doing Gradle updates can be a hard maneuver since we might not be able to reuse many of the cache entries. Is there a recommended approach to deal with this context? I feel like that's a big question.
Yeah, I actually don't have a good answer for that. That's something that I think more of a support customer solutions team would have more real world experience with, where you have large projects and then you update like the Gradle version. How does that impact the caching behavior? I actually don't know the answer to that. Maybe if you send us an email or something like that, we can put you in touch with someone who can give you a correct answer. I don't want to give you wrong information.
Yeah, perhaps contacting us over the Slack or sending an email would be a good way to get that answered. Okay, so that's all the ones that are on Q&A. I'm just going to have a quick look through the webinar chat to see if there's something here.
Yeah, there are.
Okay.
And there is one Q&A incoming.
Right, so I think that's this. Okay, I see what you've posted. Gradle Build Cache is awesome. Thank you. That's awesome. It reduced build time a lot. Next bottleneck is time of Gradle tasks fingerprinting input. Gradle reads every dependency jar, calculates their hash. In our case, the dependency class path is up to 1 gigabyte. Fingerprinting can take up to a minute. Are there optimizations to this bottleneck? It does say, of course, reducing the number of dependencies should be the first solution, but like, I guess he means other than that.
That is fantastic. Like, if anyone needs caching and any optimizations, it's your project. Yeah, wow, that's a lot of dependencies. So, I mean, those are things that have been optimized heavily on how quickly it can like try to get the fingerprints and the hashes. There may be room for further optimization, but at some point, it's just that there's a lot of work to do, and there's like a minimum. There's only so much you can do, right? So I don't know, like, if you've experienced like problems with that, like it has to look at the inputs and create a hash, and there's a bottleneck to how quickly it can do that. Once the inputs get very large, there's only so much you can you speed up. I don't know if there's more headroom that can be improved with that. If that's something that you're experiencing a pain point, I would recommend opening up a GitHub issue and starting the conversation with the engineering team there. I'm not qualified to sort of know the details on how that hashing happens and whether there's room for improvement, but you can definitely start the conversation with the people who are actually involved, and maybe there's something there. But yeah, I wouldn't know off the top of my head. Yeah.
It's good advice. Another good question. In Develocity, how can I configure a maximum retention period so that older data is automatically deleted? Are we talking about older cache data or older build scans?
Cache data, even build scans, I guess. This can be done through the Develocity UI. Trisha, maybe you know more about this, but
you were going to ask me
something that can be configured in Develocity.
I don't know exactly how to do it. I just know that you can do it. So it is possible, because data retention is obviously a very key thing for most of the organizations. So the first thing I would do is check the documentation, and then if it's not there, again, go to Slack or raise an issue on GitHub.
I would concur that it's definitely going to be documented. So if you check out the Develocity docs, it's going to be there for sure.
Yeah, the link is in the chat. So
thanks, Oleg.
Thank you.
Right. There's another one here. They're a little bit out of order in the chat, so I might be missing something. We've been using GitHub Actions Cache for Gradle builds by using the setup Gradle step. How would you rate this against the remote cache provided by Develocity? I don't know if either of you have an opinion on that.
Sorry, could you repeat that? I didn't quite.
We have been using GitHub Actions Cache for Gradle builds by using the setup Gradle step. How would you rate this against the remote cache provided by Develocity?
Well, actually, do you want to take that? Oh, we've lost Oleg.
Oleg's busy answering questions.
Yeah, I actually don't know about this. So
Oleg, do you know?
Mm-hmm. For what? So for Android one.
The
GitHub
Actions one.
Yeah, GitHub Actions caching versus Develocity caching.
Okay, sorry. So basically, what GitHub Actions caching does, it basically transfers the workspace between the builds. So it leverages the local build cache functionality that can be copied over. Sometimes it can be intelligently copied over between the builds, but it's still a delay, firstly, for saving cache after the build, then restoring the cache. And again, if we talk about large-scale GitHub installations with, let's say, dedicated agents, etc., it might be quite a long time. So it's basically the same concerns as we referenced when switching to distributed cache. Local build cache is quite good, but remote cache just gives you much more flexibility for certain scenarios.
Thank you. Okay, another question. I'm trying to make sure I haven't done any duplicates because I'm trying to read lots of things at once. We're working in an Android project where developer machine runs the debug build and the CI machine runs the release build. So most of the tasks are not getting hit from the remote server when developers run the debug build. So if I understand that correctly, the stuff that's being built in CI is not the same stuff that's being built locally by the sounds of things. Any recommendations for this approach?
I can take that one. You should just have a duplicate remote job that does exactly what developers need. And I would actually say in that case, the build that is doing the non-debug that developers don't use, that is not useful to put in the cache at all, I would say. There should be like a separate local cache for just that machine, or maybe like a separate remote even cache. But like, honestly, like, if developers aren't benefiting from the outputs of that job, then there's no point putting that in the remote cache. It's not being used by anyone else. So instead, bring up a different job that is going to do stuff that developers will benefit from, even though like you're not releasing that, it's still benefiting your team. And that would be the way I would sort of handle that.
Yeah, the CI machine that runs the release build should just cache locally, not remotely, and have another job with CI machine that does a debug build, caches remotely so that the developers can actually benefit from it. So you should update your setup.
And I would also argue that it's useful to have the CI build run that anyway, even if it wasn't for the remote caching, because you might be able to catch errors in some central place rather than on individual developer machines.
Very good, yes.
Does Build Cache have better performance if we integrate Gradle plugin for GraalVM native image? That seems very specific.
I'm sorry, I don't have experience with that plugin. Again, for those specific questions, there are two options available to get a better answer. First is to reach out to the plugin community. They might be able to know something. Or if you reach out to the caching channel in Slack, or if you open up some conversation in GitHub for Gradle, someone might be able to help you. But for that, I would actually say the people who use the plugin and author that probably will give you a better answer.
I agree. I do feel like that's probably one of those questions where the answer is it depends. And so you need to ask someone who knows what it depends on. Okay, final question, I think, because we're coming to the top of the hour. What hashing algorithm is used for hashing?
I actually don't know that off the top of my head. I think the answer is it depends on what is being hashed. So like files versus like, configuration options, things like that. I think it's actually using different techniques for hashing that.
Actually, I think if you're hashing a task that is not a test task, it is hashed differently than a test task. So the algorithm depends on what type of tasks, first and foremost.
I have actually looked at the code that does this a little bit, but it's been a while, and I didn't write the code, so it's just like browsing it out of curiosity. It is all open source. You could look at it yourself as well. But yeah, if you're very curious, you could ask a question in the caching channel in Slack, and maybe someone from the engineering team will be able to give you a more precise answer.
And you can also search in the Gradle user manual, just search for fingerprinting or fingerprint, and you'll have some high-level information there. And again, once you're ready to hit some deeper level information, just read the code. It's on GitHub.
I said that was the last question, but we've got a really good last question. And so I'm going to read this one too. So it says, my team works on a larger multi-module Maven project where tests take a long time. I'm new to Gradle. Can we also avoid re-executing tests when no inputs have changed? I feel like there's actually two answers to this. One is like, I'm not sure if they're asking if we had this in Gradle, would it avoid rerunning the tests? Or we could also mention the Maven build cache plugin.
Yeah, great. So the two answers to that, like Trisha alluded to. Number one, yeah, if you were using Gradle would not re-execute the tests unless inputs have changed. That means either the test files have changed, source files have changed, or something like that. So yeah, by default, it'll use up-to-date, which is the incremental builds. And even then, even if something has changed, it will still try to use the local cache and remote cache and save you a lot of time. Running tests is very expensive. That's actually a very expensive part of your build. And yes, the test tasks do make use of incremental builds, local caching, remote caching as well. And there are lots of time savings there that do happen in real life. Now, the second part that Trisha alluded to is that, guess what? Develocity's, all these build caching features or remote caching do work with other build tools as well. So they do work with Maven as well. So Maven can make use of the Develocity remote cache as well. And you store stuff in Develocity's remote cache for Maven builds and make use of that as well. So that's something you can take a look at as well if you want to continue using Maven and still make use of the remote cache.
Great. Thank you very much, everyone, for your time. Thank you to the attendees because you've been asking some great questions. You've been very engaged throughout this whole time. Thank you to Oleg for managing everyone on the chat and answering a bunch of questions. And most of all, thank you, Akshay and Laura. That was a really helpful session.
Had a great time. Thank you, everyone.
Thank you all. And thanks, Trisha, for hosting.
Thank you. Bye, everyone.